Good morning, and today we're going to be looking at increasing and decreasing functions. So let me just demonstrate that to begin with. Now here we have a graph that is rising until it gets to the turning point, then it starts to fall, and then it starts to rise. So the points in which the graph are rising, we say the graph is increasing. And where the graph is starting to fall, we say the graph is decreasing. And where the graph is starting to rise again, we say the graph is increasing. So that's all we mean by increasing and decreasing functions. Okay, now I'm going to mark off the turning points on the graph here because obviously there are distinct differences to the left and to the right of those turning points. So we can see here that to the left of the first turning point, the graph is continuing to rise. So we say the graph is increasing. Now, if we were to draw the tangent to that curve at any point to the left of that first turning point, we would find out that the gradient would be going from left to right upwards. And if the gradient is going to be increasing when the tangent is touching the graph, then we know that dy by dx is going to be greater than 0. Okay, so we have dy by dx greater than 0 that represents an increasing function. The gradient of the line of the tangent at any point on that particular part of the graph would be positive. So if the gradient would be positive, dy by dx will be positive because the gradient and dy by dx are the same thing. Okay, now let's look at the middle section here between these two turning points. So we can see that the graph is going down the way. So between here and here, the graph is now decreasing. Now, if we were to draw a tangent on any part of that graph, we would have a line sloping down the way. So if the gradient would be negative, then that means that dy by dx would also be negative. So if the gradient would be negative, dy by dx would be less than 0. And that would mean it's a decreasing function. So if dy by dx is less than 0, then the function is decreasing. And now we're looking at this part of the graph here, which is where the graph is increasing again. It's going up the way from left to right. And again, any gradient of the tangent on any point on that graph would be positive. Okay, so if the gradient would be positive and the gradient being equal to dy by dx, that means that dy by dx will be positive. So for an increasing function here, we have dy by dx greater than 0. Okay. So if we work out that dy by dx is greater than 0, then that means that the graph, which is what y is equal to, is increasing. If we're told the graph is increasing, the function is increasing, then we would be able to say that dy by dx should be greater than 0. Remember, because dy by dx is the same as the gradient. If we have a decreasing graph, a decreasing function, then dy by dx is less than 0 because the gradient would be negative if it's going down the way, isn't it? From left to right. So dy by dx will be negative as well, which means dy by dx is less than 0. So let's look at an example here. Find the interval for which the curve is increasing. So if we were to look at the graph, okay, whereabouts would that graph be sloping up the way? Okay, so the function is increasing when dy by dx is greater than 0. Okay, so here we have our original graph to begin with. We find dy by dx, multiply with the power, subtract 1 for the power. So the first term becomes a 4x. The second term becomes a 3, because the x disappears at this stage and the constant negative 2 just completely disappears. So we have a 4x plus 3. And if we know that the function is increasing when dy by dx is greater than 0, we can now make this greater than 0. So the function is increasing when 4x plus 3 is greater than 0. Because we've just worked out that 4x plus 3 is what dy by dx is equal to. And we know it's increasing when dy by dx is greater than 0. So we now rearrange that. We take the 3 over, make it a negative 3. And we take the 4 over and make it a divide by 4. So the answer is that x is greater than negative 3/4, and that is when the function is increasing. Now let me just show you this original quadratic, the original parabola on this graph here. So this is just to demonstrate that we have an original quadratic function There's your negative 3/4, because that's your turning point of your graph, negative 3/4. And what we're saying then is that where x is greater than negative 3/4, that's where the graph is increasing. That's where the graph is starting to go up the way from left to right. We've worked all that out. That's what it means graphically. Okay. So we know that dy by dx is greater than 0 for an increasing graph, an increasing function. So we find out what dy by dx is equal to, and then we make dy by dx equal to greater than 0, and then we rearrange it and get what x is greater than. Okay. So that's the range of values for where the function is increasing, i.e. sloping up the way, and it's to the right of negative 3/4, so that would be where x is greater than negative 3/4. Okay, so here we have a more complicated one. Find the intervals for which the function f of x equals x cubed plus 3x squared minus 2 is increasing and also decreasing. So again, we know that we're going to be starting off with f dashed of x in this case. And if it's increasing, we know that f dashed of x should be greater than 0. And if it's decreasing, f dashed of x should be less than 0. So let's find out what f dashed of x is. Multiply by the power, take 1 off the power. So the first term becomes a 3x squared. Then the second term becomes a 6x, and the negative 2 disappears. Okay, so we now have what f dashed of x is equal to. It's equal to 3x squared plus 6x. Let's deal with one of these things at a time. So let's look at where the function is decreasing. Okay, so we'll look at where the function is decreasing, and we know that that means that f dashed of x is less than 0 for the function decreasing. The slope of the derivative should be sloping down the way. So the graph of the derivative would be negative. Okay, so 3x squared plus 6x is less than 0, because we've just worked out that f dashed of x is 3x squared plus 6x. We know it's decreasing where the derivative is less than 0, so we've got 3x squared plus 6x is less than 0. Now this one's a bit more complicated than the original one, because we can't just say so x is less than 0 or something's less than 0 or whatever. We have to actually now start to solve it. Now this is one of these ones that what we've actually done here is, if we go back to the quadratics topic, we have now created a quadratic inequality. And what I mean by that is, on the left hand side we have a quadratic function, and we have an inequality sign in between the left and the right hand side. So we have a quadratic inequality. Now I can't go from that step there to the final answer without drawing a little sketch of the graph, as I showed you in the quadratics topic. So we take it over to the side and we make the quadratic inequality an equation. So we have 3x bracket x plus 2 and make it equal to 0 instead of less than 0. Just so we can see that where it crosses the x-axis. So that means that x is equal to 0 and x is equal to negative 2. Now we sketch the graph. Remember how we work out where the graph crosses the x-axis from these two roots here, negative 2 and 0. But we also look at the coefficient of the x squared, which is a positive. The number doesn't matter, but whether it's a positive or negative, it's a positive x squared, so it's a happy graph, so it's a smiley face. If that was a negative x squared, it would be a sad graph, and it would be an upside down U-shaped face, an unhappy face. Okay, so it's a smiley face. It crosses it at negative 2 and 0. So for this part of the question, we're trying to see where is the function decreasing. So for this part of the question, where is f dashed of x less than 0? So look to see where the graph is below the x-axis. Here it's below the x-axis between negative 2 and 0. So there, that's how we write it, that x is between negative 2 and 0. Okay, we use the inequality sign that's given in the question. X is less than 0 and negative 2 is less than x. Remember, those two inequality signs have to go in the same direction. Okay. Right, so we've got two parts to answer. We've answered the part where the function is decreasing. We now have to answer the part where the function is increasing, but we've done all of the work for it. So the function is simply increasing, where f dashed of x is now greater than 0. And this is, remember, your graph of f dashed of x. So where is f dashed of x greater than 0? To the left of -2, which is where x is less than -2, or to the right of 0, which is where x is greater than 0. So we've done all the work. It's just a matter of stating it differently now. So we say that the function is increasing when x is less than -2 and where x is greater than 0. So this is more practice of solving a quadratic inequality. And as I said when we did it at the time within the quadratics topic, that we can use this quite a few times within other topics. It really is something that permeates other topics. So as soon as you realise you're starting to solve a quadratic equation, but it's an inequality, you have an inequality sign in between the left and the right hand side, you have to use a graph to be able to see where it is above the x-axis or below the x-axis. And that's how you would answer that question. Okay, now I gave you a question there where I asked you for both increasing and decreasing, so we had to do them both separately. Quite often you would maybe just be asked one or the other. This one's a little bit different. So this is one of these, show that the curve which is given is never decreasing. Now if a curve is never decreasing, then what does that actually mean? That means that dy by dx could never be 0. So we had something like this before when we were trying to prove something could only ever be positive and things like that. So let's just start to find what dy by dx is and see where it takes us. So let's do dy by dx, multiply by the power. Now 3 times a third is just 1, so that's why it's a 1x squared, which is just an x squared, plus a 2x, plus a 1, and the -4 will disappear. And just notice when you are doing this, every power that we have here becomes 1 power less. Okay, and that's like an x to the power of 0 in that one. Right, so if we're trying to see if we can prove that dy by dx can never be negative, then let's try to factorise, okay? And if we factorise that, we end up with 2 brackets, an x and an x and a 1 and a 1, so we have x plus 1 and another x plus 1, which is actually x plus 1 squared. Now that's what you're looking for if you're trying to show something can never be negative. Okay, you're trying to show dy by dx is never less than 0. So, and that's actually us proving that, but we have to write our statement. No matter what value of x we put in here, we will never get a negative value of dy by dx, because any value of x will become a positive because you're squaring it. So for the curve never to be decreasing, we need dy by dx to be greater than or equal to 0. And we can see here that this bracket here is always going to be greater than or equal to 0, because the result of squaring any number is always going to be either 0 or greater than that. So we can write a statement here. Since dy by dx is never less than 0, or dy by dx is never negative, the curve is never decreasing. And that would explain that. So it's a bit of a harder question, that one. But we've seen that type of thing before when we were doing our quadratics topic. Okay. Right, so we're now able to have a look at exercise 6L. I've got a selection of questions picked out for you to try to get you through the exercise. So 1A, C and D, 2A, C and D, 3, 4 and 8. And as always, ask your teacher if you need any help, and good luck.